Okay, so this video is about probability with the addition rule. And basically, we're talking about mutually exclusive and overlapping events. So let's get started. So this lesson is about that. And the first thing we're going to talk about is mutually exclusive events cannot occur at the same time. So mutually exclusive events cannot occur at the same time. That means the probability of one event does not affect the probability of the second event. To find the probability of mutually exclusive events, add the probability of both of those events together. So what I mean is this. I'm going to come up with a basic example of mutually exclusive events. Suppose we have the days of the week, right? These are just the days of the week. And the days, of course, are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now, I gave you a question that was, what is the probability of choosing a day of the week that contains the letter M or the letter F? What's the probability of choosing containing the letter M or the letter F? So we first decide whether or not these events could actually happen at the same time. Like, could we choose a day of the week that has both the letter M in it and the letter F in it? And the answer is no. There's no days of the week that have both the letter M and the letter F. So these events happen independent of each other. You can't have them both happen at the same time. You can't pick a day of the week that has both of those letters. So we say these are mutually exclusive events because one can't happen at the same time as the other. So in order to find that probability, we basically find the probability of the first plus the probability of the second. So we want to find out how many days a week, what's the probability of choosing a day of the week that has the letter M, where 7 days of the week and only one has a letter M. So I'm going to put a little box here to do the math for it. So the probability of event A or event B happening is basically the probability of event A plus the probability of event B. That's what it is. So if that's true, the probability of event A is 1 out of 7. The probability of event B, that it has a letter F in it, is also 1 out of 7. So together, 1 out of 7 plus 1 out of 7 is 2 out of 7. There's a 2 out of 7 chance that you just choose a day of the week that has a letter M in it or has a letter F in it. Again, these are mutually exclusive events because they can't happen at the same time. Now, my second question is different. My second question is, what is the probability of choosing a day of the week that it contains the letter, this is an S, it's a letter S, contains the letter S or the letter N? So in this case, we got to decide whether or not both can happen at the same time. So the days of the week, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. The ones that start with letter S are Sunday and Saturday. The ones that contain the letter N are also Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So you notice how this Sunday has 2 circles around it, not 2 rectangles around it? That means it occurred in both sets. It occurred in a set that has the letter S, and it occurred in a set that has the letter N. So it occurred in both sections. So in this case, we have an overlapping event because it occurred in both sections. We say this is overlapping. So in this case, these are not exclusive. Like, you can't have one that fits both descriptions. You do have a word that has both a letter S and a letter N. So because of that, we have to use a different formula in finding its probability. So in this case, the way we answer this problem, this probability is overlapping events. This is overlapping events. So this probability of A or B would be the probability of A plus the probability of B, take away the probability of the ones that overlap, so A and B. So in this case, this is what we write. Because we got some that overlap more in both sections, we don't want to count it twice, so we subtract it out, and then it's still true. So we did this problem. It says, what's the probability of choosing a day of the week that has a letter S in it or a letter N in it? With the letter S, there were 2 of them. 1, 2. That's 2 out of 7. So to get the letter S in it, we had a 2 out of 7 chance. To find one with the letter N in it, we had 1, 2, 3, 4. We had a 4 out of 7 chance of finding one with the letter N in it. But we got to subtract out the one that has both. This is the one that overlaps in both. So this is one of them that actually exists in both sets, that overlaps in both sets. So take away 1 out of 7. So the answer to this would be 6 out of 7, take away 1 out of 7, gives you 5 out of 7. So there's a 5 out of 7 chance of choosing a day of the week that has either a letter S or a letter N. So the answer to that would be 5 out of 7. But now you see that you do have formulas that's different than just the probability of the first plus probability of the second. Because in some events, you have words or symbols, whatever, that occur in both sets. So anyway, that's my lesson on finding the probability of events or overlapping events.